pretty garden without plants. Have you ever heard of chemical garden? It consists of plant-like structures formed by dropping a seed crystal of a soluble metal salt into an aqueous solution of one of several anions. Ions are formed when electrons are removed from or added to atoms. If electrons get added to atoms, they form negatively charged ions called anions, such as aluminates, borates, carbonates, chromates, cyanopherates, phosphates, or silicates. The most commonly used anion, however, is silicate, present in sodium silicate, water glass. And hence, chemical gardens are also called silica or silicate gardens. As the name indicates, the chemical horticulturalist will observe a growth of fronds similar in form to plants, taking place over a period of minutes to hours. This was of interest to 19th century scientists who were interested in the origin of life. Materials required are a large glass case, water glass used to preserve fish eggs in aquariums, the following metallic salts of about 1 millimeter size each: copper chloride, copper sulfate, lead nitrate, manganese sulfate, aluminium sulfate, ferrous sulfate, ferrous chloride, copper nitrate, nickel sulfate, cobalt chloride, cobalt nitrate. What to do? First of all, put a thick layer of sand in the glass case. Now pour water glass and add plain water in it. Metallic salts like copper chloride, copper sulfate, lead nitrate, manganese sulfate, aluminium sulfate, ferrous sulfate, ferrous chloride, copper nitrate, nickel sulfate, cobalt chloride, and cobalt nitrate are embedded in the sand properly. Make sure that the case does not shake, as this can displace the salts. After a little while, you can witness the emergence of exotic colorful plants of different sizes and shapes. It can take a few hours for the garden to come up completely, but when you wish to change the water, you will have to siphon it off carefully without disturbing the sand. How it works? Certain metal salts, especially those of the transition metals in D block of the periodic table, form precipitates when placed in the sodium silicate solution. As the metal salt dissolves, the resulting solution is less dense than the surrounding silicate solution and so rises up through the solution. As it reacts with the silicate anion, stalagmites, like those found in caves, form from the bottom of the jar upwards. These are insoluble metal ion silicates. The surfaces of these insoluble silicates behave as a semi-permeable colloidal membrane across which osmosis can occur. Water from the sodium silicate solution travels across the semi-permeable membrane of the metal ion or sodium silicate precipitate to the higher concentration of metal ions that are present on the inside. The water pressure inside the gel-like structures increases until the membrane bursts, thus allowing more of the metal ions to react with the silicate solution to create new membranes. This process repeats itself until the metal salt is fully dissolved, thus allowing the crystals to keep growing upward and sideways. As the metal salt solution is less dense than the sodium silicate solution, the precipitate tends to grow upwards.